Welcome back. We're going to continue. Our next speaker is Tracy Van Brakle, mostly recently an expert member of technical staff with AT&T, has been a co-chair and key contributor within mobile wireless open source projects and standards development organizations in the past 10 years. While with AT&T, he served as the technical director and principal investigator of the NTIA PWS CRF project. I think I ran into Tracy. Tracy may not remember me, when. We did. Yeah, and I've been looking at her and just say, I remember this name very well. She's continuing as a co-PI and consultant with both projects, along with a few others. Our primary focus area is in integrating and ultimately commercializing open RAN technologies and open source components using interfaces driven by GSMA, TMF, 3GPP, and most recently, ORAN. She holds 17 active US patents. I think she's being kind there because I know she has some international patents as well in wireless technologies. Before joining AT&T, Tracy was a senior technologist with Goldman Sachs, and she has been an IEEE member since 2016. Over to you, Tracy.
Okay, is my audio okay? All right, so obviously I have a very tough act to follow. Professor Galil's talk was inspiring, and I don't know how inspiring I'm going to be, but I am going to talk about a topic that's of interest to educators, and it's 5G open source stacks as tools for learning, innovating, and commercializing. And I'm not going to talk about ORAN because everybody's probably sick of ORAN. There's been so much hype about ORAN, but I've been a member of the ORAN Alliance. My days at AT&T, AT&T is one of the founding, I think the only North American mobile network operator founding member. And we are finally getting to the point that ORAN is not just talk. We are actually getting it working. And the way we're getting it working is with open source reference designs. Because of course, ORAN Alliance is all about disaggregating, virtualizing, open interfaces, and what used to be special purpose hardware and baked in is becoming software. Components are becoming abstractions, and the vision is that we will have a 5G NextG mobile wireless world that's programmable end to end. So Professor Galil, we need all your students. So let me hit a page. Do I have a clicker or what here? Okay, is this the clicker? Ah, okay. All right, so I'm going to do a brief introduction. I know everybody knows, if you heard about open source, so I'm not going to belabor some of the early material. These are my old slides, which is fine. They're not the new slides. Oops. Okay, so I think everybody's aware that this all started with Linux about 30 years ago. When Linus Torvald, if I'm mangling his name, correct me, well, don't correct me later, decided, Unix was great. Of course, AT&T is the birthplace of Unix, but he was going to write his own operating system, democratize it, make it available, called it Linux. I think that was back in like 1991 or thereabouts. And voila, we have open source. We have a way for back then, it was the internet revolution, and everybody was all excited about layer 2 switches and layer 3 routers from a networking perspective, and all of the protocols and all of the the potential for the internet. And open source and open source reference designs allowed a bunch of people who would have been closed out to get together and collaborate and contribute. And again, starting as Linux, and think of any layer 2 or layer 3 protocol or open industry standard or open source abstraction, start tinkering with it with your friends, and then next thing you know, you have something that's sort of commercial, and the next thing you know, you've got everybody in the world using email, which started out as SMTP, the Simple Mail Transport Protocol. Similar things going on right now. 5G absolutely, oops. Yeah. Okay. Oh, these are my new slides. Thank you. You scared me. Okay, that's my first slide. So now, not because I'm amazing the way Professor Galil is amazing, but because the community came together. Open source software is a big, big deal, and it's everywhere. And you're going to find it in places where people say, no, it's not secure, we don't use it. That's nonsense. And it's going to become even more ubiquitous because of 5G and the Open RAN revolution, which I know it started over 10 years ago, and there's been a lot of talk and not a lot of action. That's about to change. And that's about to change not only because of open source, but also because of an influx of US government funding and funding from other governments around the world. So our problem is that the standards that change all the time. And of course, as soon as the O-RAN Alliance publishes a specification, there's another one that's being drafted and a new thing comes out in 3 or 4 months. And most of these that are standards that are most in flux and specifications, they tend to be those for the most futuristic features. It's very hard for commercializers to do anything with these standards because they don't want to, some of you might be old enough to remember, Betamax versus VHS. They don't want to bet on the wrong horse. So we need a way of, getting these, and of course, delaying means we expose ourselves to significant security risks. So we need a way to get things working. We need what used to be called a software-driven standard in advance of the commercial availability of all of the components you're going to find in an open, programmable, secure 5G NextG system. So you can't wait for formal approval, widespread adoption of standards. You need to be able to tinker and get it to work with open source. And of course, open source is not just code as we know it, it's also evolving data modeling languages, and not just Yang. And I love it that Yang is yet another next generation. So we at AT&T, and I'm not at AT&T anymore. I learned a lot at AT&T, but AT&T, our primary duty is to our shareholders, and now I'm saying, well, maybe it's time to work more in the community, picking up where DARPA left off with open programmable secure 5G and collaborating with Linux Foundation networking, 5G Super Blueprint. The goal here is a full architecture. So with just software, we should be able to assemble, test, turn up. Of course, you're not going to virtualize the transmission medium, whether it's fiber, copper, or over the air. But with just software, it is actually possible today, all open source software, to build your own 5G network. And unfortunately, the software that you need for the base station, which in O-RAN is a CUDU, doesn't come from the O-RAN Alliance, but it comes from other open source communities who are now working in tandem through memoranda of understanding with the O-RAN Alliance and Linux Foundation networking. So the big advantage, lots of advantages of open source software, but one of the big advantages is increased code visibility. And that's very important not just as a teaching tool, but also for security. Everybody says, oh, open source is not secure. Well, that's probably true if it's done wrong, but with open source, you can actually see what's broken and you can actually scan it and identify vulnerabilities. With proprietary implementations, you don't know what's going on. And then of course, the whole notion of portability of open source, decoupling the hardware and the software and having, some of you may remember the notion of a generic MIB, a management information base back in the day. I know I had a project with switches and routers and point-to-point microwave radios from 20 different vendors. And if it weren't for, the generic management info base from Simple Network Management Protocol, we would have had no telemetry whatsoever. Same thing, same kind of, it's like nothing's new again. Nothing's old, everything that's old is new again. We're going to be doing the same thing with mobile wireless. Just like we had the Cisco effect after we succeeded with the internet, and Cisco had a stranglehold on anything having to do with it. It was Cisco or Cisco or Cisco. Little by little, we said that's no longer acceptable. Cisco has to adopt open industry standards at a minimum. Proprietary extensions are fine, but we've got to have true multi-vendor interoperability, and that's all software. So we have this early iteration of a super wireless RAN blueprint, and I'm sure everybody's sick of seeing ORAN architecture diagrams, but what's cool about this is all software that you don't have to buy. And if you're a farmer in the heartland, or you're a businessman in sub-Saharan Africa, and you need mobile wireless communications, you can set this up fast and cheap without, and I'm not going to name names, but there are a couple of vendors and they're Scandinavian and they're really expensive. They do great work, but very few of the hypothetical farmers in the heartland, businessmen in sub-Saharan Africa, can afford what these Scandinavian suppliers sell. And then the only other option, of course, is Huawei. So if you see here, we've got the ORAN concept of a service management orchestration framework, and that's just the brains of the whole 5G system. You've got a non-real-time RAN intelligent controller, which is what you need to run applications to automate, optimize, self-heal, part of optimization. I'm not going to talk about near real-time RAN intelligent RIC because that's too futuristic. And then down below, you've got an OpenDU and an OpenCU from the OpenAirInterface. That's the equivalent of a base station. And Roger, you're my colleague at AT&T. You know how expensive base stations from the dominant incumbent vendors cost. This costs nothing, except for the excellent investment in a degree from Georgia Tech, or an institution as good, not that there are many that are as good. So the whole idea is let's get the same crowd of, and I like the word tinkerers, who started learning Linux and doing cool things with K-shell and Perl and I mean, there's just so many examples, SHOP 3, SHOP 2, and let's democratize 5G, NextG mobile wireless by making it something that anybody with a degree from Georgia Tech can do himself. And of course, you're always going to have to buy a radio, but guess what? There are software-defined radios. Those are pretty cheap. The open source reference architecture for the service management orchestration framework, it's already mostly there because of the work that's already occurred in the Linux Foundation networking with wireline networks. A lot of mobile wireless people are snobs. They're like, oh, I don't do transport. But the reality is that there's always cans in a string, even if the string is over the air. So a lot of the basics for, OA&M, operations administration or automation and management, fault performance, we call it FCAPS. A lot of that stuff is there, and we're beginning to reuse it in a way that is truly multi-vendor and makes all of these different pieces truly interoperable. And pieces, I mean, not just macro, but macro, distributed antenna systems, indoor solutions, outdoor solutions, private and public cellular networks. And of course, you can't ignore the cloud, because the vision is once you have the RAN once you have a 5G system that's software, you run it in the cloud. And once you are serious and are capable of actually programming it from end to end, you need places in the cloud where you can distribute your applications so that you get optimum performance. And sometimes that's centralized, and sometimes that's at the edge. So Linux Foundation networking, I don't know who's done much work with Linux Foundation networking, but they're definitely, yeah, I know Ashutosh, yeah, it's, I figure quite, yeah. So they're really leading the charge. And again, that would not be true if it weren't for funding from DARPA. DARPA, and before that, it wasn't DARPA, it was ARPA. What was the name of the federal, the internet? ARPA, DARPA. And now, of course, in addition to DARPA, we've got, well, the National Science Foundation will recover from what the new administration has done to it. I'm sure that will happen. But you also have NTIA, Public Wireless Supply Chain Innovation Fund. And we'll talk about that when we're going to go learning, innovating, and then commercializing. So srsRAN. srsRAN is quasi-open. They do have a commercial product. You can actually cobble together srsRAN commercial products with OAI, with, software-defined radios that look and smell like open radio units from the ORAN Alliance. And again, Virginia Tech do this, and we're also doing this at Rutgers WINLAB summer session with summer interns. And it's a great way for somebody who's a young computer scientist and a networker and an AI, a future AI expert, because it's not just, we need people who can do everything. We need one person who understands computer science, open industry standards, RF, radio frequency technologies, the PHY layer, basic, layer 2, layer 3 networking. And basically, if you take the graduates from Georgia Tech and you make a lab environment available for them, doesn't mean they all have to move to Georgia. They can still, work online, but they can go to the community college around the corner and do an exercise in a lab. If they're, doing anything with networking or anything with robotics, it's the one thing that I want to follow up with Zvi about is let's see if we can make some lab resources available, and we're doing that coast to coast with NTIA, but we'll get to that after we go through the next section about learning, summer students projects. So big things, and I don't want to explain the obvious because a lot of people already know this. Open source software, OSS, it's affordable and accessible. It's, readily available for students, cheaper than any textbook that any college student will ever buy. It's perfect for underserved or poor communities, back to the farmer in the heartland and the guy, somewhere in Uzbekistan herding goats who needs to have smart goat herding that's 5G enabled and maybe even AI enabled. And it encourages collaboration among students, educators, developers, and when I say developers, industry. So, industry, corporate America, their prime directive is their shareholders. However, that means, staying technologically advanced and viable, not only domestically, but internationally. Here's a way to do it, and we've done several projects with universities and AT&T and Verizon and Ericsson and Samsung and NIST and NTIA, and it's a formula that works. Customization and flexibility. If you buy proprietary software, it typically does one or two things, unless you buy the optional modules that'll make it do more, and before you know, you've spent thousands of dollars, and the module that you added this year is not backward compatible with the base platform that you bought 2 years ago, and it's a mess. Open source software also requires lifecycle management, but it's customizable, it's flexible, it can be adapted to meet specific learning needs, and it can also be adapted to meet specific business needs. Active learning and engagement. You let students work together on a project with open source, especially if it's open source that has to make a robotic dog do something or build a real 5G network. They're going to have fabulous hands-on experience that will complement and augment what they've learned at Georgia Tech. Real-world skills, again, working with open source projects prepares students for real-world professional environments where it's all about collaboration, problem solving, continuous learning, plus CI/CD, continuous integration, continuous development, delivery, deployment. These are all essential skills, and I don't think that working in isolation with a commercial product is going to impart those skills to the workforce of the future. Innovation and development, we'll talk about that as we move farther along. Open source education, again, open source principles, practices, tools, prepares students for careers, not only in the tech industry and beyond, but also for careers outside of tech. I think that learning how to program in whatever it is, Python or Perl or C or C++ or Linux or whatever it is incredibly useful as an intellectual discipline, no matter what you do. And transparency and trust. Anyone can examine the code, understand how it works. It's kind of like my brother did me a terrible disservice when I finally got my driver's license, and he gave me his 1967 Chevy. And it was unsafe at any speed, but he said, "Oh, Trace, it's great. It's anybody can fix it." So right to repair is a big thing that we don't have with quite a lot of the technology upon which we're already hopelessly dependent. And of course, flexibility and adaptability. So WINLAB, Rutgers University, has an amazing summer internship program. I think we have an alumnus here, right over there. And I've been working with their summer students for a few years, and we've actually brought in more students, which was quite amazing, bringing in midshipmen from Annapolis, as well as a couple of cadets from West Point. What we've done over the past couple of years is we've worked with these kids on a project that NSF is funding called Indigo. And we said, you guys learn a little bit about ORAN, start writing some R apps. In order to write an R app, the student has to understand not only, the whatever programming language he's going to use, he also has to understand, the data, the behavior of mobile wireless networks, the interfaces that are constantly changing. It's one thing I love about the ORAN Alliance. As soon as you think you know to do something within one of the ORAN interfaces, there's a new one, even Open Frontal, which is the most mature. And write R apps to do some real things. A couple examples here would be, resilience. Let the farmer say, oh, I have this smart cow milking scheme that has to work no matter what. So I need to be able to detect if, I've got 3 networks and they have overlapping coverage, and I need to be able to detect if network 1 fails, and then power up and increase the capacity of network 2 to compensate for that. I have sensors on the cows that says, are they happy cows? Have they been milked? So there's a lot of complexity I don't even think the industry has a definition yet for resiliency. It just means bounce back ability. We have notions of availability and reliability, but resiliency means anything that can break will break. How do you bounce back? How do you detect that and recover quickly? Security. I'm not super hung up on security yet, but let's face it, we cannot ignore security. Something real basic like making sure that if a radio from untrusted vendor or bad actor wants to connect to a base station because they're disaggregated, that is somehow detected, disallowed, and that hypothetical radio is quarantined. And then, of course, you have an RF that says, oh, if my base station can't use that radio, I got to find another radio that my base station can use in order to maintain coverage in the hypothetical area. And then, of course, frequency. Now, this was the beginnings of, now everybody's all excited about dynamic spectrum sharing. This was just something, teaching tool for students to start understanding, how to deal with frequency, how to, deconflict spectrum. This is, and these students, some of them were gifted and talented high school kids, and some of them were master's degree candidates or beyond. So we, the students did all of this. They said, okay, figure out a functional diagram, figure out the implementation. Pretty much everything here is open source, OpenAirInterface, of course, Docker, Amerisoft. I don't think there's anything here that is not open source. And let's use software-defined radios. Again, back to the notion of let's not shut students out or shut anybody out of these technological advancements because they can't afford the stuff. Once upon a time, we had Heath kits. I don't know, somebody must be old enough in the room to remember that. Okay, how many kids learned, how to make, things, learned about electronics and how to make, electronic devices that could conceivably become commercialized. I don't know how many of them did, but same concept. And I'm not going to talk about the SMO, plant UML, having a notion of, who talks to what and who talks back. This is also open source tool. It's very easy to teach somebody with, basic computer skills how to use it, but figuring out how to get the bang for the buck is a little bit harder. And it trains your mind to really understand the problem statement as opposed to, what we call the glittering generalities. Topology service. So this is just an example of what our students did. And this was not in a vacuum. This was foundational work for a project, National Science Foundation Convergence Accelerator, operating securely through TrackG. How do we, incubate this concept and get to the point where we can have a truly multi-vendor open RAN that is in fact programmable, that can be multi-operator, meaning multi-operator cooperation beyond what exists today with just 5G roaming, and realize the vision of ORAN, which is AI-enabled programmability end-to-end, to achieve a specific purpose that is always going to be integrated with a mission or the physical world. The mission could be milk the cows. The mission could be, holy crap, Russia's coming in through Kaliningrad, make sure Latvia, Lithuania, and Estonia can share communications and, resist. Frequency app, and then of course, it culminated in this beautiful poster that it's mouse print, but we have a quick demo if we have time at the end, from a PhD candidate at Columbia University who, all open source, developed this mission UX We're calling it an RAP, which is not exactly fair because it's not containerized and it's not onboarded to the SMO yet, but the SMO meaning the Service Management Orchestration Framework, but we'll get there. So once you use open source as a learning tool, then it becomes a tool for innovating. And again, we have this, we taught a bunch of students and we're paying them. I think, Professor Galil said, you can't expect people to be volunteers forever. It's wonderful how much work you can get out of students if you have as much coffee as they can drink, unlimited pizza, and you pay them. So they are the ones who are doing most of the development, and our vision is we want to be able to recover and restore wireless communications during civilian disasters. The asteroid hits Sheboygan. And we want to do that by introducing intelligence, cooperation, and automation across both public and private networks, because we want to make sure that we have, there's no reason why the last mile or the last acre has to be a gazillion dollar, 5G, NextG macro network. We want to make sure that, again, democratizing mobile wireless, because right now it's anything but democratized. And our customers or our beneficiaries would be first responders, search and rescue teams. Of course, the military will, we hope, benefit from this, but we're not talking about them because that's scary. And whatever we do has to be secure, resilient, has to, be able to, I'm not going to say share spectrum, but deconflict spectrum, and deliver quality of experience that can be integrated and that can be intelligently controlled end to end. Right now, we're not going to go anywhere. 5G by now was supposed to be able to, deliver telerobotic surgery. Well, would you want to be in the back of an ambulance and have open heart surgery being performed on you when you cross over from, you do the handoff from Verizon to AT&T, and you're like, ugh, I don't think so. So we absolutely have to move beyond the limitations of 5G roaming. And quality of experience can't just fall off a cliff because there's a handover. This is intended to, again, we want to be realistic. We don't live in a perfect world. We need to be able to integrate and orchestrate not just 5G and NextG, because, the Yanomami and the Amazonian rainforest, maybe they have 2G. And certainly in many parts of the world, 3G is about as good as it gets. So we have to have an all-G approach, and our goal is to have flow-through provisioning and complete recovery after the asteroid hits Sheboygan in 3 minutes or less. And that means that if everything's blown to smithereens, we bring in a cow. Cow, of course, is a cell site on wheels, cell site on wings, cell site on the water. There are AT&T working with Naval Postgraduate School has been working on cell sites on buoys that self-power through the tides. And, I kind of like the whole concept of MOO, multi-operator orchestration with cow. Okay, all right. And then, of course, the FCC is not unaware of the problem that we have with insufficient cooperation, collaboration. I can't say that licensed spectrum is a quaint anachronism as we move to 6G, because I have colleagues I deeply respect in AT&T and Verizon who would shoot me, but we have to improve the resiliency, the reliability of mobile wireless networks before, during, and after emergencies, and that means, taking down the fences that wrongfully segregate operator A from operator B in areas with overlapping coverage when the asteroid hits. So, this is an example. This is actually a real example. This is New Jersey. This is my backyard before Hurricane Sandy. And everything's fine. You've got operator A, You can imagine who that is, operator A, AT&T, operator B, B and V, Verizon, and everything's fine. Each network has, all their access points are working, everything's normal. As you can see, there's overlapping coverage. When Hurricane Sandy hit, both Verizon and AT&T networks were hammered, but they weren't completely obliterated. And if we had had some method of pooling resources across these two networks and, doing some reconfigs, we could have restored service in hours or maybe a day. And where I lived, service was out for almost a week. So, and then of course, once you have this multi-operator service management orchestration framework, there are lots of things you can do as you've brought up this, let's call it a public safety emergency network, not to be confused with FirstNet, because this is different from FirstNet. Then there's a lot you can do. You can say, oh, I got a message from a paramedic that, yes, there's a head trauma victim, buried under rubble, prioritize communications to the search and rescue robot. We were fortunate to have a tour with Angie, who's one of the lab directors here, and saw the robotic dogs and the flying fish. So, a lot of this is going to be, for robotics. So high-level architecture, all open source. Now, interestingly enough, now that we've got all this open source, commercial products are beginning to emerge. And that doesn't excite me all that much, except if you can't commercialize it, it's not gonna be viable. Again, you only get so far with volunteers. People have to make money. This is an ecosystem, and all animals in the ecosystem have to find a way to feed themselves through the winter. So I'm very pleased that this concept of a service management orchestration framework, we have it implemented in open source. Ericsson, I wasn't going to talk about them. They're beginning to commercialize it. Of course, I have to say Fujitsu commercialized it a long time ago for OpenROADM, layer 1, and now they have also a commercialized service management orchestration framework. Likewise, some of our apps are slowly but surely getting commercialized. And that's important because, we really need to have a vibrant ecosystem, a supply chain that's fixed, so we're not hopelessly dependent on the big five. And the big five, of course, are Ericsson, Huawei, Nokia, Samsung, ZTE. And none of them are in the United States. We're not hostile with, I'm not going to say anything about China because I have great respect for Chinese scientists and engineers, but we're not hostile with the Scandinavians, but, it's pretty sad that the United States doesn't have, an alternative to these 5 dominant incumbent vendors who have a stranglehold on mobile wireless. I think Huawei's profit recently went through the roof, and vendor lock-in is their special talent. So, okay, so I'm going to skip through this. In addition to open source for the programming of these disaggregated, virtualized, we'll call them abstractions because that's what some of them are. There's also a need for APIs that don't exist today that will make it possible. Again, we're moving closer to not only multi-vendor, but multi-operator. And multi-operator not just domestically. The roaming agreements were great when they were first thought of before some of us were born. But their limitations are very real, and these these new APIs, and you can, if you're interested in the slides, you can, look up any of these APIs. Some of them you may already be familiar with. It's now possible, for example, to do SIM swapping across operator A, operator B, and verify and validate that the user identified with a SIM is in fact the legitimate, user and not some scammer or spoofer. So that was what these were for initially, was to prevent, you'll never prevent fraud, to reduce fraud. Just like you'll never stop cheating in universities. I mean, a student has a duty to try to cheat. But smart students know that they're just cheating themselves, but fraud will never go away. So get rid of this, okay. So these emerging memoranda of understanding, and here's another opportunity for our workforce of the future, for our computer scientists, the graduates of the online masters in computer science degree, also need to understand public policy and also need to understand the gibberish that is all too often found in 3GPP documents. This particular memorandum of understanding covers the MDRI, Mandatory Disaster Response Initiative, and then of course, and that's for civilian purposes, and then of course there are memoranda of understanding for military purposes, again, not just in the United States. The MOU for the Quad Alliance is getting formalized by NTIA GCOT, and we need computer scientists who are also policy analysts, who also are experts with, RF phi layer and AI enablement. I mean, and I'm glad I'm not in industry anymore, because I feel sorry for industry trying to hire. You're going to have to hire 5 guys, each one with the skills that you need in order to get this all to work, unless you have one person who can do, who has a reasonable degree of expertise in all 5 areas. So it's computer science, on steroids, and networking. Networking used to be, cans and string, right? And it was all point to point, and mobile wireless with everything cloudified, and that's no longer the case. So we are doing a proof of concept, learning a bunch of new stuff, and back to the punchline here. So once we learn something new that belongs in the open, we need computer scientists, and they need to learn it preferably in high school. I know when I was in high school, there were hobbyists doing all sorts of things with Heath kits, and then as soon as I got out of college, the first thing I learned when I went to Goldman Sachs was Perl and K-shell, and we need to start these young people now learning to understand what's the consequence of a lack of standardized integration with IEEE's, we're here at IEEE ACM, spectrum consumption model. Does that necessitate another memorandum of understanding? Who's going to write it? I mean, most of the really good programmers I know are not exactly literate, and I say that with affection and respect, but we need excellent coders who can write sparkling, clear prose as well. RApps and XApps, we're all excited about dynamic spectrum sharing, but the reality is that, the current RApps and XApps don't know anything or can't do anything with respect to real-time spectrum sensing and interference monitoring. We talk about it. Oh yeah, we're going to do, dynamic spectrum sharing and, ISAC and it's all science fiction. It won't always be science fiction. And we need to, start getting this. Very much excited about the summer program, WINLAB, Rutgers University 2025. We're going to have students who are working in this area, not just at Rutgers WINLAB, but the other university labs that comprise the Accord Cloudified Federated Lab as a Service, which is where we go from innovation. We started with learning, innovation. Now we're going to go to commercialization. Ashutosh, am I running out of time? How much time do I have? Okay. If possible, it's only 2 minutes. I don't think I can play it at the end. Okay. Okay, if you could play, yeah.
So we have also some questions.
Oh, yeah, okay. Do you want?
I have a question too, but.
Okay. So this is our student. He's a PhD candidate, Columbia University, John Drogo, and he completely open source.
We see here on the left the Mission Planner UI, and on the right we have a view into the back-end logs of the system, which would normally not be visible to an operator, but we include for system transparency.
See, overlapping.
When an operator is first presented with the display, they can zoom into the area of mission region of interest, which we have outlined with these polygons. Here we see a mix of green and red circles indicating the status of various networking equipment in the area of operation. If, for example, we click on one of the red circles, we see that this represents an RU's emplacement for operator D, which is currently offline. And likewise, one of the green ones indicates an area that is currently online. If we were to a moment assume the role of a first responder search and rescue team, we would likely need coverage in a virtual slice that we're going to be sending our teams into in order to ensure that they can coordinate to communicate back to base station, what have you. If we assume that the outages in this case were the result of a natural disaster, this naturally means the search and rescue teams will have to encounter infrastructure that's going to be partially degraded. By leveraging our system, the operator behind the computer can define a bound for a virtual network slice. And despite the degraded network capabilities for some of the hardware, we can send a request to the backend system to stitch together the remaining component in order to restore comms. In this case, for example, we can specify a high bandwidth link is required. When we hit submit, our request for the mission plan is sent to the backend system, which then attempts to fulfill the request. And we get as a response the network state as a whole. We can see here that we get a summary of what are the different capabilities and what the different failure or success states are for various links and nodes in the network. Additionally, we can use the settings tab if we want to adjust the parameters that the AI planner is using to make the decision and to navigate the configuration space efficiently. And when done, the user can still return back to the original network view to understand what the status is for the various network equipment for situational awareness. We see here on the left the Mission Planner UI, and on the right we have a view into the back-end logs of the system, which would normally not be visible to an operator, but we include for system transparency. When an operator is first presented with the display, they can zoom into the area of mission region of interest, which we have outlined with these polygons. Here we see a mix of green and red circles indicating the status of various networking equipment in the area of operation. If, for example, we click on one of the red circles, we see that this represents an RU's emplacement for operator D, which is currently offline. And likewise, one of the green ones indicates an area that is currently online. If we were to a moment assume the role of a first responder.
Okay, so that was an example of what a very talented, again, he's a PhD candidate, so he'll be teaching the class soon, using an open source simulator a member of our team is the project technical lead with the simulations project in the ORAN software community, as well as using, well, the AI planner in this case is not directly integrated because there was a glitch with that, but the AI planner is also open source. It's based on SHOP 3, Simplified Hierarchical Orderly Planner from DARPA, originally from DARPA. What he was talking about, what John was talking about as the back end, an open source service management orchestration framework, and some open source netconf models as stand-in for management plane of real ORUs. So Roger, correct me if I'm wrong, I don't think we spent a dime on commercial software to do any of this. Yeah, so, and this really could work. Now, of course, industry is going to say, oh, we need a single throat to choke. We can't have, contributions from all these different open source projects. We've got to get a commercializer. Great, just as Red Hat commercialized Linux, let's get whoever it is who's going to commercialize this, or maybe commercialize the pieces of this. And we kind of called it an R app, but that was some poetic justice on our part. It's not really an R app, but the next iteration, it'll be appified, or more R app-ish. So before I move on to commercializing all of this, were there any comments or questions?
Sure, Tracy, I think this is an excellent talk. Just to complement Zvi's democratizing the education, you are trying to get the testbed, hands-on experience.
Yep.
So my question is, I'm so glad you're talking about this. You've been part of this IEEE 5G6 innovation testbed. That was one of the main reasons we created that, so that people around the world can take advantage of that. So now you'll probably in a better position to collaborate with IEEE 5G6 innovation testbed.
We are.
To augment the objective that you have, right?
Yes, we are.
Yeah, thanks. I know Brad, Gloja, and the rest, they're watching it. So.
And we are very interested in fulfilling the mission of NTIA, Public Supply Chain Wireless Innovation Fund, which is to expand the availability, affordability, and accessibility of testing and evaluation resources nationwide, so that, Professor Galil's students can be West Coast, East Coast, Uzbekistan, not just nationwide, and not only get the advantage of online instruction, computer science, and the theory and everything, but also do things hands-on in a lab environment.
Yeah, so the question's about 6G and how it is focusing on integrating new technologies like non-terrestrial networks and native AI. And the question is there any funding or government-initiated open source community to define 6G systems?
Yes, there is. That's a great question. Within the National Science Foundation, which is one of my favorite organizations anywhere, the CHIPS and Science Act created the first new directorate that's been created in the past 30 years, and it's called Technology Innovation Partnerships, TIP, not to be confused with Telecom Infra Project from Facebook. They're TIP, NSF is Technology Innovation Partnerships, and there's a project there with annually renewable funding called POSE, Pathways to Enable Open Source Ecosystems. And I'm proud to say that while I was at AT&T, I was part of a proposal with Northeastern University that's funded and includes guys from OAI, as well as Linux Foundation, networking, and ORAN software community. And we don't talk about 6G, those of us with friends who are at AT&T and Verizon, because that creates the false impression that 5G is legacy. That's why we talk about 5G, NextG, but there is federal funding from the National Science Foundation and also from NTIA, Public Wireless Supply Chain Innovation Fund, which I'll talk about next.
Yeah, why not?
Okay. All right, am I running out of time? I'll be quick.
5 minutes or so.
Okay. Okay, so we talked about commercializing. The United States government did one of the best things they've done in a very long time. And that was the CHIPS and Science Act was, supported. It was a bipartisan initiative, Republicans and Democrats. It's one of the few things that the new administration is not going to undo because it's just so popular in blue states and red states. And it aims to facilitate the adoption of open, interoperable wireless networks through all of the good things that you see here that I already talked about. So we were very happy to find out that the requirements, and this is straight from the NOFO, this is Notice of Funding Opportunity number 1. So far there have been 3. It's a 10-year program, $1.5 billion. Well, I was at AT&T, and Roger and his team deserve a great deal of the credit as well. We were one of the big winners of NOFO 1. And we were delighted that the requirements were our requirements. NTIA actually heard what operators in the United States and around the world had to say. Like, why are we stuck and still, trapped in this vendor lock-in? Why haven't we been able to succeed with Open RAN? So we're increasing the availability, affordability, and accessibility of T&E. I'm not going to read this whole thing, but the important part is expanding access, including small and medium-sized companies, startups, and SETI, socially or economically disadvantaged individual-owned businesses, so that we start incubating not only the technology, but also the future workforce, but also the entrepreneurs. And the cloudified federated lab as a service that AT&T and Verizon, I'm going to pass through this, that we built out and powered up recently. It's based on building on pre-existing indoor-outdoor city-scale test beds, but thanks to the miracle of federal funding, making sure that these test beds had the latest and greatest commercial products from all of the leading vendors. You name it, their products, if they're anybody in 5G mobile wireless, their products are in one or more of these test beds, either because they were funded we bought, NTIA dollars bought products from them, or they recognized the importance of having a presence in these test beds. So we are expanding this. NOFO 2, I'm going to go through this real quick. So that was Notice of Funding Opportunity 1, and we're already working on Notice of Funding Opportunity 2, which is funding newcomers who are commercializing radios. And in some cases, these radios are software-defined radios. And as you can see, there's, the award range for this ORU commercialization, $25 million to $45 million. And if you want to see the awardees, just Google NTIA Public Wireless Supply Chain Innovation Fund. We are, meaning me and my role at WINLAB, as well as AT&T in their role, are partnering closely with some of these new suppliers of the technology of the future. And commercialization is great, but it's also innovation. And when you're dealing with innovation, you got a problem, because they're saying development has to be targeted for 5G standards that aren't ratified yet. So what are you going to do? Well, you're going to use open source and do some tinkering and implement something that kind of is consistent with at 3GPP or a standard or an ORAN specification, and then, some of it'll work and some of it won't, and then you just keep building on that software-driven standard, and eventually you'll have, a product. So I'm sorry if I went over time, but there is a lot of support, not just in the United States, but worldwide, to succeed in our lifetime, I mean, like within the next 2 years, with this technology. And it's a great opportunity for a lot of people in this room and for a lot of students. Thank you very much.
Thank you, Tracy. Any other question from the audience in the room? You have a question?
Thank you for a great presentation. I know that you talked a lot about the open source ecosystem. I think you had a really good picture, like back on slide 7 or so. I guess my question was, I guess even here in some of the work that I've done with open source 5G, we see that there are a lot of different software vendors who are, or like even open source projects who are working on some of the same things. Like there's multiple different, like there's srsRAN and OpenAirInterface. And I was curious if you saw that as like potentially like duplicative work, or if there's some benefit to that.
So that's an excellent question. There's a lot of duplication and there's a lot of fragmentation. And it's too soon to discourage that, but absolutely the day of reckoning and convergence has arrived. So I would envision a time when we as a, we meaning us, we make a decision. We say, oh, srsRAN has a killer DU, distributed unit, and OAI has a killer CU, and we, control unit, and we say the other open source community's attempt will be discontinued. And that's not going to be done, I don't think that's going to be done through some, central planning committee. That's going to happen naturally. Just as, I don't know if you remember a long time ago, we had, there were 2 SDN controllers. There was the Open Daylight SDN controller, and then there was the ONUS, the Open Network Operating System network controller, and they were constantly competing against each other. And eventually it was like, Open Daylight is the de facto standard. And ONUS, which is the ancient Greek word for jackass, just kind of went away. So that's going to happen. Yeah, that's a very good question, because fragmentation is a big problem, and duplication.
Thank you. I appreciate this perspective.
All right, so let's So again, Tracy, it was such a wonderful talk. And so we have
I get a goodie bag.
Yeah, both. We got a goodie bag too. So this is a token of appreciation.
You spelled my name right.
Yeah, so Tracy. So of course I have to, right? Association Computing Machinery Baltimore Chapter and IEEE extend its appreciation to Tracy Van Brakle. She used to be my colleague at AT&T. We worked together for many years, for delivering invited talk titled 5G Open Source Stacks as Tools for Learning, Innovating, and Commercializing. You does all the 3 things, right? You have to make money and ACM Baltimore Chapter 8, Seminar 2025, Laurel, Maryland, April 3, 2025.
Thank you very much.
Okay.